Okay, so we are all welcome again to the Analytics Project Management track. And as the name sounds, it's a combination of project management and analytics. So for project managers, what they do is basically see to the proper execution of project. And execution of project, for it to be timely, for it to be resource managed, and for it to also deliver on the project. So there are like three aims of every project manager: to deliver the project within specified timelines, to also manage the resources on the project, which includes human resources, and then to also deliver on the goals of the project. So sometimes goals might also be to deliver on the agreeable terms of the project or to make your customer or client happy. And in analytics, your goals are constantly being renewed by your data and also by your customers' request. Your customers' request in the sense of what are those things they want to, what are those insights they want to get from the data. So when you work in an analytics firm, sometimes you have what you call ad hoc requests. So ad hoc requests are sometimes not in your project plan. They are sometimes not, you know, agreed before the start of a project, but because the more you dig into it, into the data, the more insights you begin to drive out. So the ad hoc request might be coming from you to your client. It might be a request as well from your client saying that, oh, I would like my data to give me insights in this area. But as an analytics person in working within the team, you should be able to understand that this is how analytics is structured. And when delivering to a client, you deliver within project. So many other times you hear that, oh, we are is either as a data scientist or a data specialist, you are either into research or into executing projects. So you find people in the academics or people who are working with academicians or attending conferences and seminars and all that, doing research. So research also is within a scope and also within timelines and then delivers on certain goals, right? But that's for researchers. But now, as a non-researcher, you are either executing private projects, maybe for yourself, or you are within an organization and you are working within or delivering on a project. So you must strive to understand what the project entails. You must strive to understand, you must also strive to understand your clients so as to be able to deliver goals that are specific or are interest that your clients are interested in. So that's like an introduction into what analytics project management entails. So please understand, this is even a project management summary. Every project must deliver within timelines, must deliver within resource, and must deliver on goals, on agreed goals, agreeable, agreed goals that are feasible and executable. Because sometimes your clients come to give you things that are way beyond or outside what your project scope, covers. So all that must be agreed within, the project plan. So a project scheme would have a project plan. So when you are in an organization and you are working within a project, there must be a project plan. If there's none, then you should strive to create one for yourself. That okay, within week one, within month within monthly schedule, what are those things you want to deliver? It's going to help you to be able to pinpoint your deliverables on a project. So within Octave, we have like a weekly review session, and every team member, discusses what they've been able to deliver on an ongoing project. Then between the team lead and the client, there's an agreed project plan. So your deliverables, your weekly deliverables must also be in sync, must be in line with the agreed project plan. Okay, so that being said, let's look at what analytics projects, what it looks like, so that you can be able to understand the management. So we want to look at analytics project, and then also look at the cycle within this kind of projects. So I'm going to start off with what is analytics. And I think I'd like to get feedback from each and every one of us. I just want like your own view. Like, what do you think about analytics? What does analytics mean to you? So you've been hearing about big data. Some of you guys even have experience doing some analytics stuff, machine learning, and the rest of that. So what exactly is analytics to you? You have the floor. Everybody is going to say something. I won't call names, but anybody can start off. Those who don't say something, know that I'll definitely call you. I have your list here.
Hello, Ma.
Yeah.
Yeah, so it's Ebube speaking.
Thank you, Ebube.
Analytics, for me, I believe, is more like a process or should I say, a skill or an activity of extracting insights or actionable insights from data to enable one to make valuable business decisions.
Okay, great. So it's a skill for extracting actionable insights to make business decisions. Thank you for that. Next person. I don't want you to repeat what someone else has said. Just tell me what analytics means to you in any form. So Ebube has told us actionable insights. Next person.
Yeah, I can. Hello, my this is Toby.
Who?
Toby.
Toby, okay.
So,
Yeah.
yeah. Well, another point that I would like to add to it is saying, it's a way of bringing out pictorial representations, if possible. No, no, yeah, pictorial representations from a chunk of numbers, from data, from large data.
Okay, pictorial representations. Next person.
Okay. Hello.
Okay, this is Daniel. Is anybody else talking? I should go ahead.
You can go ahead. Go ahead.
Okay, thank you, Richard. Okay, analytics is looking into the past, looking into past data, what has happened before, trying to find patterns through it to be able to fuel decisions.
Okay, great. So like digging patterns from historical records. Right, Daniel?
Yes, ma. Yes, ma.
Okay. Yeah. Next question.
So I think what I would say is close to what Daniel said. So, but just elaborate more on it. So analytics is a process of analyzing data or historical data to analyze to get the trends and patterns of what happened in the past, and also the way of looking at the future by forecasting what will happen next and what will happen for better business decision.
Analyze and forecast. Thank you. Next person.
Good
Good
morning.
morning, ma'am.
Oh,
Not speaking.
Okay.
Hello.
I can hear you. Go on. Good morning.
Okay. Analytics, data analytics is the process of like examining data sets. It can be structured or unstructured to draw conclusions about information they might contain and possibly helping to project new measures in order to solve a problem using this data.
Okay, I like your perspective. You're drawing conclusion. Okay, so that's like you're talking statistics, like you're creating an hypothesis and you're drawing conclusions from it, right?
Yes, yes.
Okay, next person.
Um, this Sunday, I think one of the purpose or the main purpose of analytics is to just extract useful information that can be used for prediction, decision making, and many other things, depending on the aim and the objective of the so-called organization.
Sorry, Sunday, number one. You didn't introduce yourself before, did you?
I did not.
Oh, oh, yes. Sorry. Metallurgical, you did metallurgical science. Okay.
No, meteorology and climate science.
Okay. Please, can you repeat yourself? I didn't hear you.
I said I did meteorology and climate science, ma'am.
Yeah, I know. Your name of analytics.
Okay, I said analytics is just the main purpose I can just drop from is that it's just to extract useful information that can be used for decision making, prediction, and also many other things, among other things, for the organization. Because sometimes the what an organization might need for a data might be different from others. So depending on that kind of organization, but the major thing is just to draw conclusion, decision making, and prediction out of data.
Okay, thank you. So I'm summarizing yours as extracting useful information for an organization.
Yes, ma'am.
Okay, so
good morning, ma. This is hello.
hello, yeah, I can hear you.
Yeah, good morning. This is Hubert. Okay.
Okay,
I want to draw some things from what Daniel and Richard said. So to me, basically, analytics has to do definitely with analyzing data that has already been collected from different organizations, it might be internal or external. Okay, you analyze the data for insightful information from the data to forecast, and forecasting has to do with you taking out patterns from previous data acquired and then predicting to what's going to come up in the future. And now you don't only predict, and you don't only forecast, you also make up this. The trends you see help you to make insightful decisions as a very good analyst to help improve on the outcomes, on the future outcomes, not just to forecast what comes, but also to have an influence on a positive influence might add on the forecast. So that's you optimizing data and utilizing it for profitability and sustainability of businesses and operations.
okay, you said a lot, but I'll summarize by you mean that analytics is analyzing data to forecast and identify patterns to improve, so as to improve existing outcomes or existing process.
Exactly, man.
Next person. Okay, let me look for.
Good morning, ma.
Good morning. I was going to fish you out. Good morning.
Okay, so analytics is an art that has to do with trying to understand data better, because you have data everywhere, but just like I've been made to understand, or I've learned over time, that it's not just having so much data, but being able to draw conclusive decisions from those data, and being able to utilize those data effectively, either through creating visuals, either through forecasting, predictive modeling, or being able to develop a machine learning model. So for me, that's analytics.
Sorry, I was distracted, but I heard an art, and then you said it should be for you to develop machine learning models and all that. Can you tell me those things I missed out in between?
Okay, so I said machine learning is an art that has to do with us understanding data better. And I made mention that we have data everywhere, all around us, flying about. But our ability to be able to utilize those data, to be able to draw out conclusive decisions from it, thereby we'll be able to make predictive, carry out maybe predictive modeling, forecasting, and also build machine learning models that would help businesses and enterprises to maximize their outcome.
Marvelous. Yeah.
Ma?
Thank you. Okay. I understand all you're trying to say, and that's why we're here to break down the understanding of analytics. Analytics is different things to different people. You've combined a lot of things together in your explanation, which is good, and that's why we are here. So you've told us it's an art. You've told us which is the basic understanding. Is an art of understanding data, right? And then you went on and on to machine learning models, building machine learning models, which is fine. So put that machine learning, you understand, in brackets. So it is an art of building models. So the model could be machine learning, it could be simple mathematical model, it could be statistical models, any kind of model, just to and please, I'm going to come back to giving you guys what a model is, maybe as I go on talking, but if I don't remember to say, just ask me. Okay, so it's good. Thank you. Who is left? I have one more person left. Tony. Tony has not spoken, no. Ibitamo Tony.
I've spoken, no.
He has spoken. Okay. Okay. In that case, then you have all spoken, but I didn't note down what you said. Okay, so let me go back to my screen now. And really, what is analytics? Analytics means several things to many people. And analytics also means different things to different industry. So depending on the industry you find yourself, you must be able to, as a data scientist, or I don't like to use the word data scientist. I prefer to use data specialist, because you have several angles to that field of data. You have even even big data engineers too. They are also in this same field of understanding data. All we are all trying to do is understanding data, working with data, and using data, you understand, to create science, right? So science in itself is, an art, and is an art of, and studying and observation and creating facts. So science deals with facts, right? And now data science, what makes the data science now means using data as a background for science. So all we are all doing, all the data specialists, all they are doing is using data to create facts, and create facts and products and stuff like that. So I prefer to use the word data specialist. So some of you guys are on the engineering track, so probably you're going to become big data engineers. Some of you guys are on the data analyst track, right? But again, we all have like a general name. We call ourselves data scientists. So we are all doing science with data. So now, the analytics part of it is an arm of data science. Is an arm of data science that has to do with applying models to create insights from data. Now, there is analysis and there is analytics. Some of you have explained analysis, right? And analysis actually transcends to analytics. Now, the difference between analysis and analytics is same as the difference between a business, let me use the word, a business analyst and a data scientist, or someone who uses just Excel and someone who is a data scientist. Now, in some organizations, you find some people and their job role or job function is business analyst. So business analysts, basically, they also work with data. So even in the track of data science, these people are data specialists. They know how to manipulate data, but they are not looking for insight in their manipulation. All they are doing is aggregating data, summarizing data, but they are not interpreting what they are doing. Okay, excuse me. However, a data analyst, a data scientist, or a business analytics, or whoever is in analytics from the data he or she is looking at. Does someone have a question or a comment? So I'm just trying to make you see the difference between analysis and analytics. However, your understanding of analysis helps you to do well in analysis. So analysis leads to analysis. Hello, someone, please unmute if you're not talking. Oh, okay, blessing. You want to say something? Hello. Hello.
No, outside, in fact, outside, you can do from next week because once we get the house, so I like tomorrow.
Okay, good. I guess he didn't know it was on mute. Okay, so basically that's the difference between a data scientist and um an analyst. You are looking at, so wherever you find yourself, anytime you have data presented to you, you should look at the data with a second eye view of generating insight. But you you start off with analysis, and then in um, in generating insights from data, mathematical equations, statistical models have proven valuable. And if you notice, many people will tell you that data science is a fusion of mathematics, statistics, and computer science. Yes, they are very right. Why? Because simple equations, helps you to explain the relationship between variables. Now, when you bring that understanding into working with data sets, and I'm sure you must have learned that in some of your past class, data sets contain rows and columns. They come in rows and columns. And in the world of computing, we identify columns as variables. So a set of numbers can be called a variable of integers. So a set of numbers simply means that you can have any number which is an integer in this set. So your set is defined as an integer. So we call it variable integer. Now, when you bring that to mathematical statements, when you say, like in algebra, when you say x equals to a plus b, what that simply means is that there's a relationship between x, between a, and between b, meaning that anytime you add variable a and b, it will give you x. Now, as a data scientist, that's the same kind of, now when you say you are looking for pattern, you are simply looking for relationship. Now, you can now explain those relationships as mathematical models, as statistical models, right? So that's what models mean, and that's the genesis of our machine learning models that we use today. Like your regression model is defined by a mathematical model of a straight line, saying that at every point in time, for any set of variable to have a straight line relationship, then it is defined by an equation y equals to mx plus c, where c is your intercept, your point of intercept on a graph or on a Cartesian plane. So I always like people to have basic understanding of what they are doing and the ground knowledge, because when you have a good foundation, it will help you to build on this. Now, coming back to our topic of interest, analytics. From this explanation, I believe you guys understand clearly what is analytics and the difference between analysis and analytics, and why we cannot junk analysis. Analysis actually leads to analytics. Analysis is simply a form of, aggregating data, summarizing data, but you are not applying insight, you are not applying models, you are not applying relationship, you are not looking for patterns. But in analytics, you're doing same thing that an analysis would do, but with an addition of a second eye view of looking for insight in that data. So you are looking for patterns, you are looking for relationship, you are putting all this together, and then you are generating insight. Or like someone said, you are making conclusion, or you are extracting useful information, you are drawing conclusion. And it is after you've drawn conclusion, you can now use that to give a factual statement to say, based on the insights I've seen in this data, based on the model that works, based on the conformity of this data to a particular model, then you can make forecasts to say, then a future variable would also behave the same way. You understand? So that's that about machine learning, test and train. That's the basic knowledge about all this. So let's look at our board together. It says analytics is all around us. We implement analytics in our everyday life to make decisions. Yes. And that was what prompted analytics. Every day, okay, so as an individual, based on the temperature, the humidity, or the look of the cloud, you can make a prediction that it will rain. So that's even like a form of analytics that, oh, you've considered that the temperature is so low, the environment is so windy, the clouds are heavy. Some people even have a sense of smell to smell rain, and based on all these 4 factors I've mentioned, then it will rain. So that's like human instinct making decision, but that was based on various data sets. So data is available all around us. Sometimes we take deliberate, as human, we take deliberate steps to track this data, and tracking data now is even easy with sensors or with deliberate way of collecting data from the field and all that. So all you're doing is making judgment or making sense from data. So let us consider the example of a retail store that serves the needs of the people in a small area. Now, the owner of the retail store is an old man who has been running the store for over 25 years. He knows all his customers well and is personally involved in every transaction done in the store. Can you all see my screen? I'm reading from the screen.
Yes, ma'am.
Okay. Sorry. Yeah, he knows all his customers well and is personally involved in every transaction done in the store. Since the owner runs a single store and serves the need of a small geographical area, he can use customer profiling and competitor analysis to understand the needs of the customer and provide them products to their requirements. This example, sorry. This example illustrates the use of analytics in a local retail store to help cater to the specific demands of the customer. So this is a clarity on what I've explained earlier. And I'll throw back that question to us. From this example, from all that I have said, what is the difference between analysis and analytics? And from this example, what is the analytics provision that was made from this example? I want to be sure that we understand analytics and the difference between analysis and analytics, because you can't manage a project which you don't understand the domain. Toby, please, can you open the floor? What was the analytics insight drawn from this example of this retail store?
Analytics insight is the fact that the store owner was able to use customer profiling and computer analysis to understand the needs of his customers.
Okay, great. Now, what's the difference between analysis and analytics? Someone else should answer. Henry. Okay, no, I don't want Henry. Henry, I will call you for something else. You work with a telecoms firm. You're going to give me an example. So, Henry, start thinking of an analytics example that works for a telecoms firm. I'll call Ebube.
Okay, sorry, what's exactly the question you asked now?
What's the difference between analysis and analytics?
Okay, does it necessarily pertain to this scenario or in general?
Yes, you can use this scenario. Yeah, you can use this scenario.
Okay, well, basically, if he was just to do analysis, he would just compile the customer profiling and competitor data and then just read or explain what exactly the competitors, like the competitors' sales, the competitors' profits, and other things like that. But he did analytics by going further to use that information from this data to predict, based on maybe past experiences or past occurrences, to predict the needs of these customers based on their profile. So we expect that if this person has some kind of social status, these are the kind of needs he would probably need, or he would probably have based on social status. So basically, that's where he did analytics, different from analysis by just checking this competitor data and just drawing maybe visualizations and things like that. Thank you.
Nice, thank you. Yeah. So some of us must have seen some stores that probably anytime, or some shops or retail outlets that anytime customers make a purchase, they just write down the product and the amount, and every day they just sum up, okay, this is my total sales made, and it ends there. So they have like a say a purchase book, yeah, or a receipt book. Receipt book is data in itself, but they are not doing anything with it, right? You have some stores too that use electronic means of generating receipt and gathering data of purchases made by their customers. But this data, they are not doing anything with it. But this guy, like Ebube mentioned, went an extra mile to profile the customer. What does it mean to profile customer? Can anybody answer? As an analytics person, you should be able to understand these terms in context. Okay, to profile a customer simply means to like classify or categorize or put in clusters to say, okay, these are high profile customers, so these ones, they have money. These ones, they are middle customers. They don't really have their spending pattern, they don't really have money. These ones, so you are classifying customers. Okay, someone say something.
Yes, I wanted to say segmentation.
Okay. Yeah, so to profile a customer can be segmentation. You are segmenting them. It could be clustering, right? You are looking at a cluster of customers and how they behave. So now profiling, you can see the way it's aligning with various machine models that you guys know about, right? So you could be profiling, then also you could be profiling a customer on different stands. You could be profiling a customer on the amount spent. You could be profiling a customer on their age, right? You could be segmenting them on their age. Also, there are different stands to this, right? So as an analyst, you should be able to, understand this concept, this context, right? Interpret them into proper data analytics model that will generate insights for your customer. Okay, so great. So the analytics done in this case was that it did not just gather the data, but it went a step ahead to profile the customer. And now, based on his profiling, he was able to create an analysis. See, an analysis which understands the needs of his customers. So it did not stop at analysis, but it went a step ahead to generating actionable insights from his analysis, right? And provide them products according to their requirements. So the business decision made here was to provide products according to each customer's requirement. So that's like optimizing the process. So before now, customers could just come and see products they don't need. But he has been able to optimize the process such that he can provide customers at every point in time with products that they need. You understand? So you can do this analysis in various forms. If it's not a very large data, you might just do it maybe on Excel. If it's a middle large data, you might be looking at maybe SQL and all that. But if it's a very large data, you might be looking at the likes of Hadoop and all that to handle big data. You understand? So is the size of the data is relative, but what makes it key is the insights you are generating from the data. And that's also what makes it analytics. And that's also now the way you achieve your analytics differs. You might decide to achieve it using recommendation engine, using simple regression. You might decide to achieve it using decision tree models. You might even decide to achieve it using models that you have generated by yourself that is aligning to some form of statistical model. You understand? So the tools and the technique with which this guy achieved customer profiling is not known. And the same thing when you are working with customers, they don't really care about the tools and technique used in achieving your analytics. What they want to know is results. So as an analytics project manager, or as someone who is involved in an analytics project, your aim is the insights generated from the data. So when you get to work with Octave, you'll notice that we are not really after Python, or maybe after the various Seaborn libraries and all that you've used in Python, or how great your machine learning models, the accuracy of your machine learning models. Your machine learning model might be very, very accurate, it might be 99%. But if it does not give any useful business information, then it is null and void. You understand? So that's the kind of understanding we always like to give to people who work with us, that, see, you are not just here as a machine learning expert. No. Your aim is working with data and generating actionable insights from that data. Now, the tools and the techniques and all that which you use to achieve this there are several tools, there are several things you can use in achieving this, but at every point in time, you must be able to use the best technique to achieving a goal. You understand? Don't forget, we've mentioned three key things about every project: timeliness, resource-based, and then goal-driven. So you must be able to deliver within these three and deliver actionable insights to your customer. So and that's why your clear understanding of analytics is very, very important. Very, very important. So when you work with an organization as a data scientist, they are not going to spoon feed you to tell you that these are the insights we want and all that. All they'll just give you is data. They just throw you into that pool of data. You understand? And then it is now left for you to start looking at the data with a second eye view, that what can I bring out from this data? What tools and techniques can I apply to this data to work on this data? But it's best to start with analysis. Analysis, summarize your data. As you're summarizing the data, it starts giving you insight. So in another class that I'm taking, we were looking at statistical summaries. Basic statistical summaries give you key information about your data, like your mean, your mode, your median. And then your mean, your mode, your median helps you to know the spread of your data. The spread of your data, if this data is skewed or if it's normally distributed. And a data that is skewed operates on different standard compared to a data that is normally distributed. A data that is normally distributed would align with various mathematical and statistical standards that would help you to generate insights about the data. You understand? So all of this information are various tools and techniques that you can use to analyze your data and then be able to draw out actionable insights. I needed to dwell on this largely because you need that clear understanding of what analytics is, so as to be able to understand the various cycle of analytics. So I'm going to move on to the next slide now. I hope we're all clear. I just want to hear, you can do a quick unmute and just tell me yes, or if you're not clear, ask a question or give a comment.
Yes, ma'am.
Clear.
Okay.
Clear, man.
Okay, that's good. So I'm going to share this slide with Emmanuel later, and then he can send to all of our emails, but just go on with me in the slide. So we've dug deep, we've talked a lot about analytics, and you can go through the slide later on to read the text of what analytics really entails. So going further, you need to, in executing an analytics project, having done your analysis and with a second eye view of generating insights, you must also be able to communicate this your insights to your end users in a way they understand. And in communicating your insights to your end users in the way they understand, that brings us to what we call visuals or visualization. Now, you can decide to communicate your results or your facts or your conclusions or whatever in various forms. Now, for people who do online competition, you simply communicate your results by sending your data sets, the result of your data set, right? Now, for if you're dealing with a technical person, you can communicate your result by telling the person the accuracy of your model, how well your model performed, and then the ROC curve, and all those technical details. But again, you must understand that when you are in an organization, when you are working in an office or an enterprise environment, you are likely to be working with business people, and business people are not technical. Many of them are not technical. So you need to be able to communicate your results of your data analytics process or project in a simple way that they can understand, in a clear and simple way that they can understand. And that's what brings us to pictorial format. Now, it's believed that pictures say a lot and they help you to communicate better. So in communicating your results, you can put together your model analysis, you can put together your insights in some form of charts. It could even be in some form of graph to show the trend that, okay, this is the trend and this is the forecast on that trend. So if I'm using a trend line, I could be showing both historical and future trend all on one trend, right? And that way they are able to, quickly align with what I'm trying to say to them. But you can't stand in front of a client and be showing the person Python scripts or be showing the person your SQL or your data sheets or your data sets. They will just tell you that they don't need your services again. You understand? So what we do in managing projects or in Octave analytics is we get access to data, we analyze the data, work on the data, do analytics on this data to generate insights, and then we put together our results in visual methods, in visual ways that can aid our clients to understand the data. So there are various visual methods. Sometimes we even use Excel charts. Excel is very good with, aggregating data, but upon aggregating the data, you are storyboarding your aggregate, your insights. I mean, you are storyboarding your charts to bring out the insight, right? So we also use tools like Tableau. We also use tools like Power BI. You understand? So for data specialists, like I mentioned earlier on, there are various areas you can specialize in. You can decide to be a visualization expert. You can decide to be a modeling expert. You can decide to be someone who is good at the back end. So you are writing data scripts and then you can decide to be like a business intelligence expert. So like a business intelligence expert is, facilitating data aggregation from the back end and writing SQL scripts. SQL script basically. SQL is general, so it could be SQL on Oracle Toad, it could be SQL on MySQL, it could be SQL on Microsoft SQL. But having that clear understanding of writing SQL is very, very important. In fact, I tell people that you need SQL knowledge much more than you need Python and Python knowledge, because your SQL is very general and across platform, and you can even do a lot of modeling on SQL without having to write a line of Python script. And if you don't know this before, you better know it now. Octave Analytics and most enterprise organizations that you find yourself are very, very big on SQL. So if you've not started learning SQL as a data expert, then you have not started. I would advise you, you can go on W3 schools online and go and learn on SQL, because the data, the DASCA course outline did not really detail so much on SQL, but they applied SQL in some areas. But please, you need that knowledge of SQL. Go and start upscaling yourself in SQL. The SQL skill is very, very important, because most data platforms are on enterprise tools that require you to be able to write SQL so as to extract or aggregate on the data. Okay, so that being said, that's that anyways. But all I'm just trying to say is that you need to be able to communicate your analytics projects to your end users. So I'll move on to my next slide. Let's now look at the process of an analytics project management, or an analytics project. What's the process? Where does it start from and where does it end? So we have an understanding of analytics now, what it entails, how it is different from analysis. We have an understanding of how you can communicate, or how you are expected to communicate your analytics insights to your clients. Now let's look at the process. What was the process for me as part of a project, as part of an analytics project? So it starts with a business question. Remember, when I told you that as a data specialist, you are either doing research or you are either on a project. And if you're on a project, you're either doing personal project or doing projects within an organization. So whether you're doing personal projects or projects within an organization, or even doing research, in research, they come up with research questions. You must be able to identify the questions you are trying to answer. And that helps you to define your goals, your scope. So an analytics project also starts off with that. In fact, data is like a pool of water that you are thrown into, and you are looking for or you are looking for a pin or something. Or no, let me use a different example. Like, okay, people say data is the new oil, Before you get to where the oil is, you have to dig. And if you don't do proper checks, you can't just be digging anywhere looking for oil. Go and ask them, okay, I have a number of you that are into petroleum engineering and all that. I'm sure you do a lot of data gathering, data checks before you then go to a site and then go and dig for oil. So the same thing too with data. You must be able to, answer various questions. Or, you must be able to enumerate the clear questions that you want your data to answer. That way you can go into that data with a clear view of what you want to achieve with the data. So for instance, you have a friend who runs a retail store, and from your interaction with that friend, you just say that each time this friend is just writing down products and what is so, just keeping a sales book. You looking at that sales book as a data analyst, you should be able to, have business questions that you can achieve with that data. Because that's a clear way to start. So this is what also translates into your business case. And that is where your analytics project, that is where it starts from. If you're also into research, you must have research question, and that's where your project as well starts from. Then, having done that, you should do what we call preliminary analysis. So preliminary analysis is like a fact finding or like a summary aggregation over your data to look for basic facts. Remember, we mentioned that analysis leads to analytics. So upon writing down your questions, your analysis process is where you now do your aggregation. You are like, okay, let's say I'm looking at employee data and I want to make sense from employee data. I should be able to answer what is the highest salary. It's basic. You understand? So when you come to work here, we're just going to give you data, and maybe after some time, we'll just call you one day and say, this data you are working on, what is the current date on the data? What is the what's the highest? Okay, so if it's employee data, I can just call you and say, what is the highest salary on the data? Which day of the week is the spending highest or something, or which day of the month from that employee data, what is the age range of the employee data? So those are important preliminaries you must know about your data. So all of that you do in analysis, aggregating your data, getting basic statistical information of your data, your mean, the average salary, your mode, the highest salary, your median, the middle salary. You understand? So your total, the total salary paid by this organization. You understand? What is the monthly salary range paid by this company to their employees? So those are basic analysis. Now, because this basic analysis helps you to have clear view of how your data or of the relationship. No, it helps you to have clear view of the relationship in your data. Now, if your analysis is saying A, and after you apply your model or create a model, the model is saying something different, then your analysis can help you to judge your model. So analysis is very, very important, very, very important. Now, after analysis, the next thing is interpretation. Now, from your analysis, you have basic information that you can interpret for a project. So if for instance, the how will I put it now? So from your analysis, yes, from your analysis, you can be able to draw out certain conclusions or certain facts, not conclusions, certain information or facts, preliminary information from your data. So, for instance, you could even identify employees that their salary are like outliers, or their salaries are very, very different from what is general. Or you can also have an interpretation of the spread of your data to say, oh, most of the employees in this company, their salary is low compared to those who have. So let's say you look at employees and their salary, and 70% of the employees are earning 20,000 naira and below. But you have 10%, just these few 10% that are earning 100,000 and above. So you can from there conclude that, oh, most of the employees in this company are earning very low salary. So the spread of your data is not even. That's what statistics means by spread. This by spread. And that's where they now draw all this kind of information saying that, oh, okay, it is well distributed. So when it is even, you can say it is normally distributed. But in this case that I've painted now, it's not even. So in statistics, they'll say it is skewed. Now, because most of them are earning low, on a number line, on a mathematical number line, lower figures will skew towards the left. So, for instance, in this data set I just described to you, you can say it is skewed towards the left. It is left skewed, meaning that most people are earning low. You understand? So those are some interpretations you are bringing out from basic analysis of the data. Now, from this analysis and interpretation, then you must be able to define your scope that, okay, from this basic information I've gotten, these are the kind of scope, or these are the kind of goals that I can achieve with this data. To say, okay, so based on my employee data, I want to do a trend analysis to predict, I don't want to use the word predict. I want to make it simple. I always don't like when people use buzzwords. It's more about understanding what you want to achieve. So now that we have employee data, we want to look at the relationship of employee data and the demographic information of the employee. Demographic information simply means information around age, sex, and things like that. So I can now say that, oh yes, so maybe we have people with, maybe we have younger employees, more younger employees earning lower amount of money. Then I also want to look at their highest level of education. Oh, okay, most of these employees earning 20,000 and below, most of them have just OND. Oh, okay, so I've looked at their education. I also now want to look at their gender. So I now find out again that most of these employees, okay, maybe 60% of those earning 20,000 and below, 60% are females, 40% are males. Okay, then you now also want to look at another variable. So you then look at, so that way you can now start looking at what is the relationship between salary, between age, between gender, between highest qualification. And then from that relationship, you can now come up with, in statistics, they can decide to come up with a mathematical equation to say, okay, this is the relationship. Anytime age is low, salary too will be low. Okay, anytime highest qualification is low, salary too will be low. So that's like a form of relationship. But to define this relationship, there are standard statistical models or mathematical models that have already defined them, right, that you can use. Or there are standard machine learning models like decision tree, your Bayesian decision network graph, or decision tree, or for complex data, you use some other complex models, or what's it called? There's this popular one too, that is classification. Logistic regression, yes, logistic regression. So logistic regression is actually for classification, not for not for prediction. It's not for continuous variable prediction, but for categorical classification. Yes. So you can decide to apply any of these standard models. So you must be able to, realize the scope within which you want to work with the data. Then you then go to implementation. So based on your understanding of the data, all the various data variables you've put into consideration, then you want to implement your model. Sometimes you might even skip this implementation and go straight to visualization. Now, reason why I said this is that not every data problem requires a model. Take my word for it. Not every data problem. In fact, 80% of the data problem you work with in data organizations does not require a model. So sometimes from your interpretation, from your realization of your goals and what you want to achieve with your data, you can move on to visualization. And in your visualization, you are storyboarding, you are bringing out insights from your data, and you are presenting this data to fuel, you are presenting these insights to fuel business decisions. Right. So and that way you have delivered on a project. So that this like a summary of your project management cycle and you being able to deliver on a project to your clients. So I'm going to move on to my next stage in absence of, is there any question before the other slides are just like a summary of all that I've explained earlier. So I'm going to run faster. But questions, comments?
I was just feeling with this flow diagram for the phases of analytics and the alignment to project management. I was thinking interpretation and realization of your data could be used interchangeably in a particular project. Like interpreting your data, when you're interpreting it, this is the result you're getting from the data, and I don't know, it's almost the same thing with realization of the result of the data. Expatiate or elucidate me on something I'm mixing up them up.
Okay, it's fine. Yeah, so the difference between interpretation and realization, if you look at the text below it, I think it's clear, saying that for interpretation, you are drawing recommendation from the analysis you've made, from the preliminary analysis you've made. You're drawing recommendation for your project initiation. So that was where I also mentioned looking at your basic statistics on employee record. You can draw other variables to say, okay, these are the other information I'm going to need to look at the relationship between this data. Now, based on all these various relationships, you can then define your scope to say, these are my goals. So your scope and your business question, they kind of go together because your initial business question is looking at, okay, I want to use this data to create an analytics insight to understand my customer, or to profile my customer, or to profile my employees, yeah, because we're talking about employee data. Now, within your scope, you are now enumerating, you are listing out that's goal one. These are the goals that I intend to achieve within this scope of project. So this is more like goal definition within the scope of your data. Is that clear? Did I answer your question?
Yeah, to some extent, I think it's a bit more clear. A bit clearer.
Okay. Any other comment or question before we move on to the next slide? Okay, good. In absence of that, then let's move on to the next slide. So, like I mentioned earlier, these are like more elaborate explanation on the cycle of an analytics project. So like I said, you have to frame your problem correctly. You understand? So ask the right question. So the right question might not also generate from you. In fact, most times the questions generate from the domain experts, the clients you are working with, your interaction with your clients. And that's why as an analytics firm, most times we work at site. So we work within our client organization, within their environment, so as to facilitate interaction between us and them. So from time to time, we ask them questions about their data, or even from the project manager from the client side. We also try to understand their business needs. So many a times they don't even know what they want. So you also need to kind of balance your ability to ask the right question by first providing like a basic report to your clients that, oh, this is your data, these are some of the insights I have generated from your data. Does this answer to the questions that you are looking at, or you want the data to answer more questions for you in this regard? So there's no rigid way to it. There's no rigid way to it, but the clarity is that from both sides, you must have a focus for the kind of question you want to use your data to answer. So that would also help you to know the kind of data you want to extract from your client end. Now, as an organization in Octave, our basic or first question that we want to answer for all our customers is to help them evaluate their customers. So like that's like a ground zero goal for us in Octave Analytics. So we do what we call basically customer evaluation. So from every of our customer clients data, our first problem is to evaluate your customers. We want to evaluate their customers for them to bring out actionable insights or profile their customer, just like we read in that introductory scenario. Our ground zero problem framework is to profile customers. So that way we are like, we want to answer for you the behavior of your customers, the transacting behavior of your customers, so as to be able to know how to deal with your customers better. Now, you might get to some kind of environment, maybe they are maybe in an FMCG, their kind of problem might be looking at their machines. You want to, they want to answer questions around optimizing their machines. You understand? So if their focus is on optimizing machines and you are coming with a different framework of problem to answer for them, then there will be an issue. You understand? So there must be a basic alignment of the problem that you want to use the data to solve. So great analysis starts with framing the problem correctly. This includes assessing the data correctly, developing a solid analysis plan, and taking into account the various technical and practical considerations in play. So the next step after framing your problem correctly is checking the business importance. Now in statistics, they call that statistical significance. Now, for people who do deliberate course on data science or on data science track or data analysis track, you will do a lot of statistics. How do I put it? You do a lot of statistics topics, And in some of those statistics topics, you hear them saying things around t-test. Even as you go on in your DASCA course outline, you are still going to do some basic statistics where they also talked about t-test or p-value and things like that. All that this is trying to show is to show the level of significance of a fact or of a problem that you are framed. So you could frame a problem. Let's say, as a retail store owner, I noticed that I have low sales volume at maybe beginning at certain times of the year, or maybe beginning of the year. Then I can start asking myself, or thinking within myself that, oh, what can I do to ensure that my sales revenue at January to March of the year does not drop? You understand? So that's a problem. That's a frame. That's a problem frame. So I want to use my data to answer that question. What can I do to ensure that my revenue between January and March does not drop? So I then begin to look at my data. What are those variables that come into play January to March? So maybe based on that, based on my analysis or based on my analytics process, I can then draw up recommendations to say, okay, December or towards January, I'm going to throw out like a freebie or like a promo to ensure that if you continue buying my product in January, you are going to get maybe a discount or something. And that way, my sales revenue, balances up or even increases. Now, for some of you for people who use GoTV and what's it called, and DSTV, you notice that during the pandemic, during the lockdown, they threw up a lot of promos saying that, oh, if you pay before your package ends, they are going to get maybe 1 month free view or something like that. So those are reactions to different variable indices that has come to play. And they don't want their revenue to drop. They want sales to still increase. They want people to still, pay money to enjoy their services. So they throw some things into play. That's how analyzing and performing analytics on your data, that's how it plays out in enterprises or in organizations. So somehow, somewhere, they must have done some clear, analysis or analytics on their data to be able to identify those kind of customers they will evaluate and throw such promos in them too. So you must be able to, beforehand or ahead of your project, determine the business importance. Now, sometimes you can use statistical inferences or statistical techniques to determine this. You can also use client engagement. In fact, most of the times, 80% of the time, you use client engagement technique to determine the business importance. So you might be working on a project or on a particular analysis, and your client tells you that, oh, this is not of priority to me now. I have a quarterly review session I'm going for next week, and these are the key things I need to drive my business decisions or drive my presentation at that meeting. So that will definitely take priority over whatever you might be working on at the moment. So those are ways of determining business importance of the problem that you have framed. For these are ways of determining the statistical significance, which I've explained to you earlier, but I told you most of the times your client engagement would even help you to know what is of clear business importance to client that you are working with. But if you're into research, these are ways you can use to determine the importance of the question that you want to, the importance of the problem that you are framed for which you want to use your data to answer. Then in many cases, you also could be taking like a random set of your total data. You might not be working on a total data in many analytics projects. So you must also understand and be able to define your sample set against the population. So for instance, in Octave analytics, most times our sample set is defined by a base. A base meaning that maybe a period, you're starting your date, your analysis is based on maybe a data gathered within certain period. So as a standard rule, we use like a 1 year base to say, okay, we're looking at employees that have joined this organization in the last 1 year, or we're doing an analysis on transactions that have been done in this organization in the last 1 year, right? Because most times your sample and your population are always two different sets, and it's always better to make quick inference from your sample set instead of looking at your population. And I'll give you reasons. Now, your population the reason why we don't always consider population is that sometimes your population could be giving you divergent views depending on the kind of problem you're trying to answer. So for instance, now, if we're looking at since inception, and we're looking at a 1 year base. Now, a 1 year base will contain the monthly cycle of January to December. Now, since inception will contain several January, several February, several Decembers, and all that. And if we're looking at transacting behavior, which differs in various months of the year, then looking at from inception might not give us clarity into the insights of our data. So sometimes it's just good to define a base to say, okay, we're looking at a year record, and we're looking at the transacting behavior across January's, across February, across March, across April, all through December. So you can't overemphasize the need for sometimes working with sample and sometimes working with population. Though working with population gives you like a total view of your data, but working with population in terms of big data is always not very feasible. So so let me use an example now. Assuming that you get a job to work as a data scientist in Google or in Microsoft. So the big threes, the big tech companies, you get a job to work with them. And they ask you to generate insights from their transaction data. These people generate No, not from transaction data, from their social media data. Now, social media data in Google might be running to millions per minute, millions per minute, millions per minute. Imagine if you now want to work on the data. Are you going to work on the data since inception till date? No. You can define your sample to a base of, let's say, in the last 1 month, or a base of the last 1 year, or a base of the last 6 months, and then and then derive the patterns from that base. Now, if you haven't derived the pattern from that base, you can use that pattern to also check on a different base. So I can decide to take a monthly base, looking at the fact that that data is very, very big. I can decide to take a monthly base, understand the pattern. Now, take another monthly base, understand the pattern. Take another monthly base, understand the pattern. So that way, you are working with data in chunks. It's always better to work with data in chunks than, getting head-on to large data. You understand? So that's the essence of sample and population. And as we all know, all these techniques generate from statistics, but they've found a way of being used in the world of computing and data science. And it's been very, very, it's been proven very, very useful for use. By the time you get into field, you are going to understand these things better. But you just need to be able to work with samples most of the time than working with population. So as a data analytics project member or manager, you should be able to understand these things and know how to apply them to working with the project on your data. So that's that about the things to consider for a data analytics project. And you should be able to make inferences and also generate statistical facts from your data. By the time you read this slide in detail, you have better clarity. Now look at what I was talking about, sample from this big picture. So from this big picture, you notice they've taken various samples of the population to be able to work on the data. And it plays out in different ways. You can decide to choose your sample based on various metrics. Now, I'll stop here. Building an analytic team is something you can read up on your own, but it's just like giving like an advice of things to consider when putting an analytics team together. Who are those set of people that should form your analytics team, and what should they be doing? And then you should be able to define clear objectives of what each member of the analytics team is expected to achieve. Remember, I told us earlier today that there are various specialty in analytics. You can be the big data engineer, you can be the visualization expert, you can be the BI specialist, writing scripts and all that. You can even be a data governance specialist. You're into documentation, you're into writing, you're into proposal creation. But all of these various special constituents require a clear understanding of data and analytics, what it all entails, so that the team is working towards achieving the same goal. So that's about analytics project management in today's class. I'm going to stop here and open the floor for comments, questions. Then I have a task here for you guys to do. I want you to envision or think of a project from any of your stakeholder. Just think of any project. Then brainstorm on, the various analytics project cycle that we've talked about today. So brainstorm on the problem you want to solve. So you are going to write a one-pager for me and submit to me. The scenario that we looked at in this class today was that of a retail store. Oh, I was going to ask Ebube, but okay, no, not Ebube. Henry, I was going to ask Henry to give me an example of an analytics project problem in telecoms, but I'll leave that as an assignment for every one of us. So look at different industry or different organization or different company. So an example was given of a retail store. So you might be looking at a bank. Another person might be looking at a telecoms organization, any kind of organization you can think of. Please do these assignments individually. So you are going to indicate the organization. You're also going to indicate, you are also going to envision the kind of data they have. So if you are looking at something like Nestle now, Nestle, people don't come to buy Milo directly from Nestle. They buy through their, their distribution agents. So you are not going to be looking at customer transactions in Nestle, no, or FMCG. You are going to be looking at maybe distribution data. So envision the data, or if you can get sample data online, is fine as well. Envision the kind of data they have, then frame a problem that they might be willing to solve. You understand? Then write the goals, or list out the goals or use cases. Goals can also be use cases of the problems that, list out the goals or use cases that you can use data to solve for this organization. Is that clear? Don't worry, I'm going to list out these things to Emmanuel and he'll share with you guys. But the class for today stops here. Any question, comment, observation?
I have a question, Ma.
Go on, please.
Thank you very much for today's class, Ma. If two data analysts work on a particular population of data set and they both pick different samples, I think it's possible they both, the insights they draw from their different samples will be different. So what's the line, like how do they come to a middle conclusion to give their to give their clients? Like, what if they both have two different conclusions? So how do they come to a middle agreement? How do they come to a middle line to draw out a conclusion for their client, Ma?
Yeah, thank you very much for that question. Yeah.
Thank
you. For research projects, you can work on samples that way. But when you're working with clients or when you are working in an organization, the sample that is always most relevant to your client is your recent sample. So if I'm looking at a yearly based kind of sample, that's a year period kind of sample, I'm not going to be looking at sample of 2018. It does not make any sense to my clients what has happened in 2018. What I'll be looking at is sample of 2020 or 2019. So in Octave Analytics, for instance, what we always measure on to do our analytics is what we call it 1 year base, a base period of 1 year. So within that base period of 1 year, which is also statistically like a sample, you are looking at all that has transpired. Now, We also have some models that we use. We do comparison between recent years, that's this year sample and last year. Like if we're doing like a comparative analytics model, we can be looking at we are in July, we can be looking at June 2019 to June 2020 data and comparing it with June 2018 to June 2019 data. So that's like a comparative analytics model. You understand? But just always know that when working with sample, especially with a periodic sample, when we are looking at a seasonal data, periodic data, your sample, your best sample is always your most recent data. Did I answer your question?
Yes, ma'am. Thank you very much, ma'am.
You're welcome. Any other comments, observation, questions? Okay, in absence of none, then the class ends here. This 12:04, I think, is a good time to end the class. Thank you all for attending. Thank you all for your time. It's a pleasure being with us all. If you enjoyed, okay. Any question?
No question. I was saying thank you very much for the class. Also.
Okay, you're welcome. One quick thing, please. I want to get a feedback. So on a scale of 1 to 10, each of you, you just give me a value, a number. So 1 is the lowest, 10 is the highest. So give me a number of how you enjoyed the class or how you have learned from the class. So we'll just follow the attendance. So you just give me a value. So I'll start with Adedeji. Just give me a number, quick one. You're on mute. We can't hear you. You're on mute.
Yes, sorry, ma. I didn't hear you well. I had a break in network, so your voice was quite fluctuating. I only had to pick a number.
I said on a scale of 1 to 10, 1 being the lowest, 10 being the highest, give me a number of how you enjoyed the class or learned from the class. Just give me a number.
6, ma.
Too bad.
A 10, it was a 10 for me, ma.
10. Thank you. Ebube.
Okay, yeah, it was 7 for me.
7. Henry. Yes. Thank you, Henry.
Yes, ma. It's a 7 for me, ma. The reason being the slides, the wordings in the slides were quite difficult to read through and assimilate while you were teaching. So since you said you're going to share the slide, I feel I'm going to comprehend it more better or later. But 7 is fair, and it was such an enjoyable class, man.
Okay, thank you. Yeah, Daniel.
Sorry. Okay, already. It's 8. Sorry.
Okay, thank you. Marvelous. Marvelous. Are you there? Okay, Toby.
$7.5.
I didn't hear you.
7.5.
7.5.
Why the 0.5?
Noted.
All these. Eh.
Personal. Thank you.
Okay, Richard.
I'll go for 8.
Sunday.
I'll go for it, man.
Okay, Tony.
9.5, ma.
Okay, thank you, everyone. It's a pleasure having you. I'll take note of somebody gave the comment on the slide print. I'll take note of that. Okay. Yeah, have a great afternoon, everyone.
You too. This is actually one of our
Very
best
much.
classes.
You too,
Bye.
ma.
Thank you very much. Bye.
Bye.
Back 10. Back 10.
But 10. If it's 9.5.
The class was
Hi, guys.
better than Mr. Bless for me.
I hope you notice.
Tusha, it was better actually.
I think this should be a private discussion.
Take care, guys.
I second.